This is May 2009, paper 1, time zone 2, question 8. And it's the mathematical induction question. So, very formal approach you should be taken to this. Let's call the statement P of n. Let P of n be the sum from 1 to n of r factorial is equal to n plus 1 factorial minus 1. And we're going to do P of 1. P of 1, the left-hand side, gives me the sum from 1 to 1 of 1 times 1 factorial, which is just 1, times 1 factorial, which is 1. And the right-hand side gives me 1 plus 1 factorial minus 1, which is 2 factorial minus 1, which is 1. That's the easy bit. The next bit is the induction step, which is where the meat of the work is, and correspondingly the meat of the marks. Assume P of k is true, i.e. that the sum from 1 to k of r times r factorial is equal to k plus 1 factorial minus 1. And I want to evaluate the veracity of P of k plus 1. So I need to get to the next term in the sequence. So I'm going to add to both sides the next term, which in this case is k times k factorial. No, it's not. That's nonsense. That's the last term in the sequence. I want to add the next one. It's k plus 1 times k plus 1 factorial. And I've got to add the same on both sides. So the left-hand side just changes. Instead of going from 1 to k, I'm now stopping after k plus 1 terms. And on the left-hand side, on the right-hand side, I just get k plus 1 factorial plus k plus 1 times k plus 1 factorial minus 1. I've left that minus 1 at the end, and I'm going to point out why. It's worth bearing in mind, and this doesn't necessarily need to form part of your argument, this might be just a note for yourself you stick somewhere. What are we trying to get to? Well, I'm trying to get, instead of getting to k plus 1 factorial minus 1, I'm now trying to get to k plus 2 factorial minus 1. This is my goal. Which is why I've left this minus 1 at the end, because that's already part of my goal. And so I don't need to do any more rearranging. Oops. I don't need to do any more rearranging to get the minus 1, because that's already there. So let's just look at the other bit. Well, I'm going to take out k plus 1 factorial as a factor. If I do that, k plus 1 factorial, take it out as a factor here, I'm just going to be left with 1, and here, take k plus 1 out as a factor, k plus 1 factorial out as a factor, I'm left with k plus 1, and this minus 1 from before is still there. That gives me k plus 1 factorial times k plus 2 minus 1, and then since k plus 1 factorial is all the numbers from k plus 1 down multiplied together, then times by k plus 2, that's the same thing, as k plus 2 factorial minus 1, which tells us that p of k plus 1 holds. So now that we've shown all the key things, we've shown that p of 1 is true, and p of k implies p of k plus 1. Therefore, by mathematical induction, P of n is true for all n in the set of positive integers.